Okay, we good? I think we're good. Test, 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 test. All right. So, all right. So this guy did it. I watched this video, and we'll watch it
You can
again.
extrude it an inch if you want.
But
It doesn't
this
matter which
just seems like
direction,
a totally
but
insane
go ahead
way
and
to
make
do
that.
this.
And then we're going to put some threads on that. So we're going to go up here to our custom features. And hopefully you've already got the thread creator. If not, you want to go to add custom features and edit. But you want to put the threads on there. You want to choose this. It's a 3/8 now. We want it to be a 3/8 10. So we're going to make this 0.1. Make the pitch 0.1. That should make it a 3/8 10. Fully threaded. Okay, so you can see the teeth on there. So, and check, go ahead and green check mark that. Now, at this point, this is pretty much the worm. All you need to do is maybe put a hole in it for the motor or maybe another connection so that it doesn't fall out. But we want
So, okay, so if we're just going to do this. So basically what I'm trying to figure out is in this design that we have, we just use 2 spur gears. And that gives us like a 4-to-1 gear ratio. But I'm thinking about like, if we actually want to make this thing work, the only way to do that is to get the solenoid onto this platform, which means massively increasing the amount of torque that this motor needs to drive. So I am thinking about, it's going to take a lot of rejiggering of things, but basically the naive thing is take this, move it over here, either you rotate this 90 degrees or you use like another gear to do it. I'm not exactly sure how what's best. So right now all I'm going to do is build an isolated part where I can just play around with a worm gear. So we're going to build a hub for the worm, set screw so that you can drive it. Yeah, let me get a pen and just try to get it on paper. See what we can do here. So it's like motor, shaft, and this can just be flush with this thing. So here is the and I'm pretty sure if we just match the pitch and the module, it should mesh, right? Okay. I'm pretty sure I can insert from another document. So I'm pretty sure I can go create document, worm drive, and then I can import. No. Can't I import from another? Derive, maybe? What? Dude, you've got to be joking. Owned by me. Okay, there we go. I just want the stepper. Okay. Nah, this is crazy. Something's bugged out. Let's see if this works. Can I just take this, copy to clipboard, and then just go over here and just paste it? Nah, see, this is insane because you can only import a part studio. You can't paste it. Okay, well, that's so fucking annoying, actually. But just, that's so lame, bro. What the hell? Okay, well, if that's the case, damn. Okay, wait, hold on. Let's just make a document specifically for the stepper then. No, because that doesn't make any sense either. So then what do you want to do? You want to, well, let's just import that thing. So derived, select part studio, owned by me, pan tilt, this thing. Is it this one or this one? I forget. Wait, why are there two? Wait, no, these are both. We want to do both. We want this whole thing. And then we'll say placement, base origin, locations. Okay, so the problem with this is I'm pretty sure. Uh, so if we select this, we select this. Okay, I don't really care about that at the moment. So now we just need to figure out. Okay, so I want a new part studio where I can just. Well, no. Okay, let's. So we're gonna sketch on here. Then we can use this geometry, right? So if we create a sketch on here and we take this and this and we do use, and then we click on this and we click on this, it's 31. So yeah, okay. So what we want is, let's think about it. Well, let me just do this. Oh, and then we don't get any of our parameters. Maybe I'm just gonna actually go back to this. We're just gonna have a mono repo of a fucking project here. So this is just gonna be the worm drive. Unfortunately, can I do derived on my own thing? Let me just do this. Okay, cool. So what am I thinking of? I'm thinking of where you build a hub on here. Okay, so I actually don't even want this thing. Let's move this way over because this is such a nonsense thing. I'm gonna delete this. So this is gonna be stepper notch diameter. Or we could just make it 25, right? Let's just, for consistency, small gear. I thought we did make a parameter for that. What happened? This is the problem with when the project grows, you end up having like so much random crap. What is it? Alt T? Okay. Small. So just look for 25s. Top mounting hole to x-axis. Top plate mount. Oh, I know what that is. That's not what we. Okay. Flywheel depth. Flywheel depth. Okay. Yeah, so it looks like we don't have any. So we're going to just do small gear hub diameter. And this is 25. And unfortunately, it's kind of like. So when we did this, I mean, the thing is, this was actually generated not by a dimension, but by a tangency or a coincidence or something. So it's kind of disconnected. Let's go to, oh yeah, okay, Alt T. It doesn't bring you to your search, which is really annoying. But what are we looking for here? I think I just part studio, right? I don't think I changed it. Yeah. So wait, let's rename this. This is going to be called Worm Drive. Okay. So here, this is now a small gear hub diameter. Okay. We want to make a circle. So we want to edit this, make this. This is going to be stepper shaft hole. Okay. And then we just want to extrude this probably by stepper shaft height. But the thing is, this is going to be minus stepper notch height because this is going to be on the notch. Okay, then on here we can do our little thing. We don't really need to make it this big, but I feel like I've been just getting so hung up on getting it right the first time. So I wish there was a program. Actually, it would be so nice to. It would be so nice to automate this thing. A custom feature that all it does is builds the set, the hub. So what do you take? It takes a face, a cylinder's face, a cylinder's circle face, I guess, circular face. This is the input. It takes that, and then I wonder if you take that face, presumably you can check whether or not it's a circle. Maybe you have to give it an edge, but I feel like if I gave it this selection, then it should be able to. And then, yeah, then you could provide, so this is the first thing. And the second thing is maybe the hex nut dimensions and the depth that you want to go, and then what's the other thing? The hex nut slash bolt dimensions. Because I have done this exact set of features that I'm probably going to do another hard code of like 15 times, and it's just like so annoying. All right, I'll show you guys. This thing is so freaking annoying to do every single time. So what did we make this? We made this 22. All right, so you make a sketch on here. You go like this. You make a construction line here. Then you make a rectangle like this. Then, oops, we got a tangency there. It'll go like this. Then this dimension is going to be M5 hex nut flats. Oh, wait, sorry. This depth. Oh, did it do something weird? No. Okay, then this is going to be M5 flats. This, wait, first off, this is a Q. Why didn't it Q? Oh, it did. This is not a Q. We select this and this, and we do Shift M, midpoint that baby. Now what's still undefined is the distance here, so we make this 5. And then that's all we have to do. Now we have to extrude this down. It's a remove, and it's going to be a M5 whack. Okay, we can just enter that. Then we want to make a sketch on here. We want to rotate around here, and then we want to make a circle. Where's that midpoint? Is that there? Oh, there it is. Okay, then this is going to be M5 hole. And then you take this and then you select like this. It's like so painful. It's that. You extrude this. It's second end position. You make this 5. It's a remove. You make this through all, I think. You need to just reverse them. Okay. Then you make another sketch on here. I don't want it normal. Now we need a polygon. We need to get concentric here. Click again. This, Shift M. Okay, now it's fully constrained. Now you gotta right click again, select other, get this thing right. And then Shift extrude, and this is going to be a remove, and it's going to be to a face, and you're going to select this face, and then you're good. Now you just have to do the mirror, and then you do feature mirror, and then you click on this thing, and this thing, and then you select the mirror plane, you click P, and then you select this, and then you're good. And now we have the hub. And actually, so now I guess this is where we could put the shaft in here. It might be a little low actually. So then, I don't know, nuts on the outside versus nuts on the inside. I don't really know. We want to do it. We want to do it here. So then what we need to do is we just need to change. Is it this sketch? I think it's this extrude depth. So instead of 9, it's going to be notch to end of shaft. So we're going to go over here. Wait, let's search for 22. Because I'm pretty sure. So wait, before we do this, we're going to select this face and this face. Should be 22. So what we need to go is back here, make a parameter. Stepper notch to shaft end. Oh my gosh. And this is 22. And then we want to go back over here, and then we want to make this extrusion stepper notch to shaft end. Oh wait, but we don't want it to be 22. We actually want it to be stepper shaft height minus stepper notch height. Okay, I mean, it's not going to change, but you might as well do it. All right, so that's good. Now, when we go to this extrusion, it's going to be stepper notch 2 over 2. It gives us a little bit more room. The one thing I'm worried about here is, hold on. One thing I'm worried about here is, dude, I wish it would just jump to this, because otherwise it's just like so stupid. We need to look for the stepper. And we want to know, I think I probably have a parameter for this, but 9. Okay, so let's look for 9. Stepper face to shaft notch. Okay, cool. It's so funny. Yeah, you need a reverse search because it's way easier to remember the numbers than these long names. Okay, so this is what we want. So as long as that is, so we need to go back now, and we need to go back to worm drive. But the thing is, the center of this is going to be 12 down. So this is going to be faced inwards. So the stepper is faced up against this thing. I don't think we can do this. I think that this is not going to work, because where is the gear going to go, and how do we, because the motor can't just be freestanding. So we're going to need like an L bracket, just like we have in the real design. How are we going to do this? Or wait, we can make this low. So this is not here. It depends on how long we want to make this and how big we want to make the gear. But then you need walls here. Yeah. Okay, so let's make a new part studio. And I just want to sketch maybe a top view. Okay, so we're gonna have wait, like this. This is gonna be a wall. This is gonna be the drive. Then this one is actually gonna go out a little bit more. And then you're gonna have another wall here. Like this and like this. And then the gear is like here. The gear is like above this. And we can make this longer, right? We can make this out to here so that it doesn't collide with this, but this is going to be low. This is probably only going to be like 50, what is it? 42, I think. Tall, but we can't have it collide. We'll just need to figure that out. And then here, these walls, the purpose of these are going to be pretty tall. And I kind of want to make it just all one part, but then actually, how do you assemble it? Yeah, you can't really do that because how are you going to get the gear into it? I guess what you could do is you could print 3 parts. You can make like a dowel, just like a cylindrical rod. Dude, I think Danny Loom just posted a... Hold on. I think he posted a... Wait, this is just not him. That's so funny. He posted something about like not using fasteners or something.
This is part 11 of building a mini tabletop bowling lane. It's kind of like beer pong, except literally not at all, and is instead bowling. This week I basically rebuilt the entire back end. The previous system worked pretty well, but I used a lot of fasteners and nuts in the assembly. And I want to minimize the amount of hardware needed to make it cheaper for you guys to make in the end. Last time I tried out these C-clips on the pinwheel, and they work super well. So I basically redesigned the whole system to incorporate them. I'm trying to use this
C-clips. Dude, okay, wait, but can we just go back a couple of frames? Actually, can I view this as a video?
This is part 11 of building a mini, and I want to minimize the amount of hardware needed to make it cheaper for you guys to make in the end. Last time I tried out these C-clips.
Let's see. C-clip shaft collar 3D print. Ah, bro. That's so overkill. Dude, why do I ever go to Reddit? Reddit is such fucking bullshit. It's literally just a C that has to deform. This thing needs to take no weight, so I'm gonna try that out.
This is a super torquey bike. It's
Bro, I've been so pissed off by
This
software
is a
lately.
super torquey
Yeah,
bike.
obviously
it's designed.
Oh my god, bro. Shit is so cringe.
This.
The Bluetooth in my car is just like so bad. Okay, do you have the geometry, the CAD for the C-clip? Is it just slightly smaller than the shaft diameter and relies? Or do you add some geometry to the shaft too? Okay. Has someone already said that? Dude, he is so cracked at mechanical design. It's kind of insane. All right, I think we can design it ourselves, but I definitely don't like having to like pull apart. Let's go back to our design. I definitely, okay, so let's just draw a rectangle that goes through here. So this is going to be like, and can we move this whole thing? Whatever. Just undo this. Redo. G. All right, so let's do it like this. So this is going to be the shaft. I definitely hate, and we're just going to put 2 on the outside. So it's literally just going to be a cylindrical rod. There's a gear here. Okay, so I think we and as long as the module match. Okay, let's just get started. Now I have an idea of what's going on. So let's make the so we can copy some geometry, but I would rather just start over. So this part, let's see. Okay, so we can still design this. We're just gonna have to make some modifications to it by basically making it 5 mils shorter. So in this extrusion, we just need to make this minus wall. I think we could probably get away with 4 mil walls, but let's just do 5. So minus wall, just so because I have all the parameters set up. Oh, but okay, no. That should be fine. The only problem is here. It's extrusion 2. This just needs to be stepper 2 minus wall, and then this just needs to be over 2. Wait, is that actually not deep enough? Let's see. What is that value? 8.5. Yeah, we can't have it sticking out, so we need to actually make it M5 whack. Okay. That should be fine. I mean, honestly, we can make it deeper on the other side no matter what. I just wanted this plane so that I know where the shaft ends. So there's gonna be a wall here. So let's just sketch on here now, and we can just start to build the worm drive. We're gonna take this face, and let's see how big should we make the maybe this will probably have some good insights.
Hi everyone. Today we're going to be modeling a basic worm gear set which you can use to transmit power between non-intersecting shafts and which allow you to achieve a very high gear reduction ratio in a very compact space. Now I'd like to start off with modeling the worm, and I'd like to think of the worm here as a rack that has been revolved around an axis. So if I revolve this rack profile around this axis and make a new body, I get something that kind of looks like a worm. The only difference is that instead of these teeth going around in circles, I need these teeth to go around in helices. Just like with the racks, we can make our worm parametric. So I've already set up the parameters. So we're going to use a module of 2 millimeters. The length I'm defining in terms of how many teeth I want it to be tall. So that'll be 10 teeth tall. Pressure angle of 20 degrees. I want a worm with 4 starts. And I want the diameter of the worm to be 40 millimeters. The first thing I want to do is model the helix. But before I begin, I'll create a new component and call it worm. And then I'll go into the surface tools and create a new sketch on this vertical plane here. I hit L for line, and I'll draw out a horizontal line that will have a length of the diameter of the worm divided by 2. And then we'll draw out a vertical line that will be the length in teeth, times the module, times pi. So that's, again, a lot like a rack. That's the only things we need in the sketch, so we can just finish the sketch, and then we'll sweep. And then it's going to be this profile along this path here. And now we need to enter a twist angle. And that twist angle is going to be the length, so how many teeth we want to advance, divided by the number of starts, and that entire thing multiplied by 360 degrees. So right now we want to advance 10 teeth, and we want to have 4 starts. So what you see now is that this thing over here makes 2.5 turns. And so if we have 4 of these put together, then we will have 10 turns in total. So click OK on this, and that gives us this surface body. And it's not really this body per se that we want. The only thing that we really want here is this helical edge on the outside. The next thing I want to do is draw out the tooth profile. So I'll go back into the solid workbench and create a sketch on this vertical plane here. And I'll project the edge of the helix into my sketch because I want the tooth profile to be centered on this endpoint here. So hit L for line and just draw out a little trapezoid. And then I'll make this angle equal to 90 minus the pressure angle. And then I'll ensure that both sides of the trapezoid are equal. I'll add a vertical line that will be the pitch line. And that line will be centered on the endpoint of the helix. Next, the addendum is going to be 1 time the module. And the dedendum is usually 1 1/4 times the module. But here I'll take 1 1/2 times the module. Because I want it to fully join up to the central cylinder that we'll add in a minute. The last thing we need to do is fix the length of this thing, which is going to be pi times the module divided by 2. Now we can finish the sketch, and there we have the tooth profile. We can now sweep this tooth. So under Create, we go to Sweep, and then the type here will be a path plus a guide rail. The profile is of course going to be the tooth profile. Then make sure that you have chain selection disabled. The path is going to be this vertical line here, and the guide rail will be this outer helix here, and that gives us a single start for our worm gear. So click OK. Then we can go into the worm gear component and hide the surface body. We don't need it anymore. And then we'll do a circular pattern of type bodies. This body around this central axis, and then we want the number of starts here. So now I have 4 bodies, 1 body for each start. The final thing I'll do is create a sketch on the horizontal plane here. C for circle. And then this will be the diameter minus 2.5 times the module. So that's just the inner diameter, generally speaking, of a gear. Finish sketch. E for extrude. Then we are going to go 2 sides. And then in one direction, we will go the length, measured again in teeth, plus 1. And that times the module times pi. So that ensures that we end up a little bit above where the teeth end. And then in the other direction, we will just do the module times pi. And then the operation will be join. And when we click OK, we see that all of the bodies are now merged into a single body. And with that, our worm gear is basically complete. Just like the rack that we've made before, this worm gear works rather well with parameters. So if I go into the parameters and, for example, change the module to 3 millimeters, we see that we get a gear with larger teeth. And I can, for example, change the length to be only 5 teeth long, and I can change the pressure angle to 25 degrees, and then we see the tooth profile change slightly. Unfortunately, the same is not true for the wheels. Those won't really work with parameters, unfortunately. So let me change this back to the original values. And before we go on to modeling the wheel, I'd first like to set up some helper components to help us with the joints in a moment. So I'll activate the root component and create a new component that I will call worm shaft. And then I'll create a sketch on this horizontal plane here, C for circle, and then let's do 10 millimeters. The dimensions here don't really matter. E for extrude, about that far up. And then I will do an as-built joint. So I'll joint the worm to this helper shaft, and that will be a revolute joint, and I'll put the origin of the joint down here. And click OK. And then I'll take this worm shaft, right-click, ground it. And the next thing we need is another new component, which we will call the wheel shaft. And for that, we'll create a sketch on this vertical plane here. So let me find the front. C for circle. And then again, 10 millimeters, it doesn't really matter. And then the horizontal distance from the center of the worm to the center of the wheel is going to be the diameter of the worm divided by 2, plus the pitch radius of the wheel that we're about to make. So that's going to be the number of teeth, which is going to be 16 in this case, times the module. And then because we want the radius, it's divided by 2. So that gives us 36 millimeters here. And then for the vertical distance, I'm going to select the length of the worm divided by 2. And that then needs to be multiplied by the module times pi. And that will put the shaft halfway up the height of the worm. So finish the sketch, E for extrude. And then we are going for symmetric with a whole length of 20 millimeters. Click OK. And then finally, also this other helper shaft, right-click, ground. Now the wheel in this case is just a helical gear, so we just do the same thing that we did in video 3. So under scripts and add-ins, we go to the spur gear. And
he does this
a module
twisting
gear with 16 teeth. We're going to select 0 backlash because we want to see how well our modeling method works. And we'll set the gear thickness to 20 millimeters, though it doesn't really matter, and we want no hole. So click OK on this. And then we go in here and pick up this spur gear and drag it out to the side for a minute. And then we activate this gear, and then we create a sketch on one of these vertical planes. We capture the position because we don't want the gear to fly back to where it came from. And then as before in video 3, P for project that in, and then from the middle we will go up by 20 millimeters. Finish the sketch, and then create, sweep. In this case, it's just going to be a single path sweep, just a simple version. So that profile along this path, and then we need to enter a twist angle to turn this into a helical gear. So let's go do some math to figure out what this twist angle should be.
Bruh.
Just like in video 3, the easiest way to think about this is to take a gear like this, cut it open, and then lay it flat. And in the case of a worm gear, what we get then is that we have a single tooth during a single rotation. And in that single rotation, it will cover a horizontal distance here of the diameter times pi. That's simply the circumference of a circle. And the vertical distance that is covered is the module times the number of starts times pi. And so if we want to know this helix angle here of this worm gear.
Okay, that seems like overkill, honestly. Should we just try to do what we are doing? So we're sketching on here. We just want to draw a circle here. Let's just make the... Does this matter? Does the diameter matter? I have no idea. Does the diameter matter? I'm going to say no. So let's just make it 20. Okay, we're going to take this and we're going to take that. We're going to extrude this. And let's just say it's like 50. Some big ass amount. Okay. So then on here, we go thread creator. Pitch is 2. Number of starts. The problem is we need a... Wait, can we just do 1? Yeah, what difference does that make? That should be fine. So we're going to do this, but now I really want to know how you do an offset face here. Because I feel like I didn't figure it out the last time we did this. Move face. And we want this to just be the other way around, and it's 0.15. Oh, wait, it did it. All right, there we go. So now it's... Oh, wait, but we... I forget exactly how we... we do this in the other one, but that should be fine. I don't know. I don't really love that. But okay, let's just say that we have, this is the worm. And let's get to building the frame, I guess. So in here, we should be able to delete all of this. So it's just... So we're going to sketch on here. We're going to make well, we could do it from here. So a rectangle like this. And then I don't want to actually switch. So this is just going to be stepper width. Okay, and then just set these two equal to each other. And then we might as well actually delete this. We're going to make this stepper width plus wall. And then do we want to do a countersunk thing if we want to mount this somewhere? I feel like I just want it to be standalone, and I don't really want to be bothered by that. So now we're going to make a line like this here. This to here is a wall. Okay, now we want to extrude both of these by wall. Okay, and then on here, we can redo this line. Kind of messed that up, to be quite honest, but whatever. Wait, is this... Is that... Wait, that doesn't look right. Okay, I guess it is. Okay, and now we want to extrude this by stepper width too. Oh, this is actually going to be the height, but it can... Okay, wait. So let me just... Okay, so this is going to be stepper width. And then we're going to want to do that freaking geometry. The problem about CAD is that once you have a good number of parts, you end up doing the same thing over and over again. And just like getting that deduplication done is like kind of annoying. All right, so we need to go back to this sketch. We need to change this to actually be stepper height plus wall. Okay, so the stepper fits in there. This goes to the top of it. This is going to have, so we're going to make a sketch on here, normal. We want, it should be in the midpoint, right? So wait, can we do our little thing here? Why are these not Dude, what? Wait, what? Oh. Okay. So now we want to draw a circle on here. Make this stepper notch hole. Oh. Okay, then we want to make a circle here. And this is going to be stepper mount hole. Then we just need to make a... Oh, unfortunately, the problem with the way that I did this... Oops. What does Z do? Okay. Unfortunately, I kind of did it. Oh, wait. That's the midpoint of this whole thing. That's why we should have done it on here. Okay, hold on. Ay, ay, ay. Okay, so let's just redo it because this is all messed up anyways. So just like this. Okay, cool. Sketch on here, normal. Okay, now do we get the midpoint? Get this midpoint. Okay, let's just do our little thing. The thing is what you actually want in this case, because you're going to be dimensioning off of them, I guess, is to do it like this. Stepper, notch, hole. Okay, and then a circle here. This is going to be step, mount, hole, diameter. Okay, then here to here is stepper, I don't know, this thing, and this is like that. And then can I say that these are equal? No. So then I have to do stepper like that. Okay, then we do oh wait, but then it mirrors that feature. So we actually want to do two different extrudes, or do we just want to do, oops, or do we just want to, I think we just want to do a circular pattern in here. It's going to be this around, wait, what? And it's 4 of them. Okay, then we just want to select all of these. Extrude, remove, up to next. Okay, so that's that. Now, we haven't really planned at all for so actually in this sketch, I probably want to make this +2 times wall. And then this is all good, but now we're going to draw a sketch on here, and this is going to be, so let's sketch on here, and then we're going to make, oh wait, let's just draw lines instead. Okay. And then we just want to extrude this. So now if we look at, so wait, let's rename this to be worm holder. What did we make this? We made this like 70. These don't need to go to the end of that though, right? They do need to be high up though. And do we want to actually give it a floor? Oh, and do we also want to have maybe a no. There shouldn't be any vertical force pressing down on the Okay, so let's just get it done. I think we really don't need the floor. So we're just going to extrude this by like 70. That's a lot. We don't need it to be 70. It needs to be like 50. Right, because it just needs to hold the center of the thing. The only thing is we need to we need to we need to extrude this up probably by like, ooh, this needs to be farther out because otherwise it's going to hit this thing. What we could do actually is just remove a bunch of this. We could just I wonder, can I just extrude this, remove, and then what is this going to be? This is going to be stepper width over 2. Then it's just going to sit in there and we have 2. I feel like that's way kind of clean design. All right, can we make an assembly file for this just so we can start to see what's up? Worm mass. Okay, we're going to insert the worm drive. We're going to insert the worm holder. And we're going to insert a stepper. Okay. So let's get this out of here. Let's just do it this way. So we're going to that guy to that guy. Flip it around. Reorient. Okay. And then we're going to take this, and this is going to be the fixed part. We're just going to take this and drag it out of here. Then we are going to take this and made it to... Oh, we don't get that circle anymore, though. That's kind of... But actually, no, but we don't even want that. We need this to be... Oh, wait, what is the diameter of this? This is 25, and this is... Oh, see, that's the problem with doing that extrude, is that it destroys the fact that this was, at one point, a circle. See, there we get the radius. Wait, is that interfering? No. So that's, yeah, that's 23. And that's 25. Okay, so this just needs to come out. Or come back, actually. So we're going to mate this to here. And then we just need to offset and it's in what direction? It's in the Z direction by, wait, first we need to flip this around. And we need to Z by stepper notch to shaft end. Oh, no. Stepper shaft height minus wall. And then it turns. Good stuff. Okay. So I kind of, okay. I kind of hate this. I want to do, so the worm holder, we're just going to change in this sketch. Instead of this, we're just going to make this 26. And then we are going to change this thing. So what is it? This mate. So this mate just needs to come all the way back. So this is just going to be stepper shaft height. Wait. No. Stepper notch to shaft in. There we go. And I really have always wanted to make this countersunk, but like, I don't know, man. Doing stuff on curved surfaces makes everything way harder. All right, so that's nice, and this turns still. We just need to make this sketch. Which sketch? It's got to be this sketch. Oh, it's the extrusion. Right, it's kind of weird how I did that. I feel like it would be way more natural to go from top view. Wait. Okay, we need to add the gear. Okay, so what we want to do now is, okay, to figure out the placement of this thing, we sort of want to know. Okay, wait. So it's going to be stepper W over 2 plus worm gear diam. Okay. And so this is the outer max is equal to outer max height worm. So then that means that the gear center height is equal to outer max plus gear or spur gear PD over 2. So we just now need to decide on how big of a gear we want to make. Okay, so let's just make a new part studio. And this is going to be the worm wheel. And then we just want to do gear. And this depth is 5 is good. I like that. The module is 2. The pitch diameter The pitch diameter, let 50? Should we do 75 maybe? Oh. Yeah, we can't. Yeah, okay. 80? Okay, and then let's just prematurely do a 0.2 just so I don't forget on the backlash. So that's pretty much all we need. We can do a hole. Where's the hole? Center bore. 10 sounds good actually. Let's do 10.4. And then I want to do those C clips. We still have to do those C clips. So to do is the C clips, shaft clips. Dude, I really like those. That's such a good can we get a frame look on that?
Last time I tried out these C-clips on the pinwheel, and they work super well. So I basically redesigned the whole system to incorporate them. I'm trying.
It looks like there is something though, right? Dude, this thing about this is period and comma don't work. It's so fucking dumb, bro. It doesn't work on the shorts. Imagine being a software engineer. That would suck. Oh my god.
This is 3 ways 3D printing improved my apartment. I needed.
Watch it be the wrong link. Obviously, it's the
This is-
wrong link. Imagine being a software engineer in 2024. I would hate my life.
To incorporate them.
Okay. Don't scroll, don't scroll, don't scroll. Okay. Oh, fuck, bro. God damn it.
This is part 11 of
Alright, let's
building a mini tabletop bowling lane. It's kind of like beer pong, except
Wait, why don't I just download the video?
this.
Will it even let me zoom in? I might have to screenshot it. Bro, what the fuck? Wait. Oh, wow, he responded. It's not slightly smaller. If you imagine an exact half of a circle goes slightly past that. So the plastic has to bend and snap. Right. Okay. That's helpful. Dude, he responded to me. It's a deep purple 1337. That's so funny. But okay, wait. But he didn't answer the fact of whether or not.
This is part 11. Basically, so I basically redesigned the whole system to incorporate.
Do you see that? How do I zoom in, bro? Dude, it doesn't let me zoom in. Literally so fucking stupid. Yeah, I wanna, oh, God. So stupid. Do you see that? Okay, see, okay. That's kind of special. Yeah, I get it. Okay, so it has a little hammer. It has a little like a hammerhead shark. I don't know how to describe it, but it indents so that when it snaps around it, it like. So just to sketch it, so um. Right. Okay. So what we're gonna have to do. Okay. So the cross beam, the thing that holds the gear in place, is gonna have a little bit of extra geometry. So we'll get to that in a second. So we're actually getting kind of close to it. So now here, how do we want to do this? Should we just do? Okay. Should we just Okay. So we decided on the pitch diameter, which is 80 mils. So GPD is equal to 80. So that means that the height of this hole needs to be dude, I wish that I could just pull up like an expression calculator, but that has all my variables. I guess the fastest way to do that is to just make a okay, so this is gonna be oh, backspace, bro. I'm dumb. Okay. I don't need to click 1 every time. If I do this, I just go back. No, wait, you do have to. All right, whatever. The expression input here is so bad, it's crazy. So stepper width over 2 plus the worm gear diameter, which is, I believe, 20. So this is going to be 10. Okay, so it's that plus 40. Oh my god, bro, they're such sticklers for this thing. And they make the input so bad. Dude, it's like, Onshape is like almost good, but it's not. Okay, so this is the magic number. So we want to copy this and make this a variable. So this is going to be the dude, that's so cool that he responded, bro. Dude, Danny Loon's so high. I feel like he's got to be in California. There's no way he's not in California. I don't know. Maybe he's not in California, but I feel like he's got to be in California. So this is going to be the So wait, let's get the sub expression down. We want the worm gear diameter. The worm gear diameter. That's pretty self-explanatory. We're gonna set that to 20, and then we'll go back in and fix it in a second. Then we want the yeah, let's just say okay, let's just say worm spur gear. Should I say wheel? I'll just say spur because I feel like I know that word better. Worm spur gear center height. This is going to be stepper. Oh wait, wall. This is from the ground. Wall plus stepper W. Oops, stepper W over 2 plus 40. Dude, what? I swear this thing is the worst. Bro, it's like, oh my god, my guy. You're killing me. I want to like this program, but it sucks so much. Wait, we forgot something. This needs to be plus worm gear diameter over 2. Okay, 76. I think that's what we had in the other guy. So now we just need to go to here. Let's undo this. And I just hard-coded the 40 because I really don't care. But this Bro, why is it so slow though? So it's this sketch, and this needs to be worm gear diameter, because we might want to change that later. The thread creator is so slow. I've also never actually printed gears from Onshape because, wait, have I? No, I've printed gears, but I've never printed threads. Okay, so now we just need to make this thing. We need to take these two. So wait, what is their height right now? It's 47. Yeah, right. It's wall plus stepper width. So what is... So we're going to extrude this by... It's going to be... What is it? Gear center. Worm gear spur center. Minus wall plus... Oh my gosh. See, that's what I'm saying. Plus stepper width. I believe that's it, right? No, wait, we need to reverse this. Wait, what is going on here? Oh, wait, we did something silly. We need to fix... There we go. Okay, but then we want to add a little bit extra, right? So let's just do like plus 10 millimeters. Assholes. They are such sticklers. They are such sticklers. Okay, so let's just make the sketch on the outside. Okay, so now we want to draw a circle here. And we want to say that it's at the midpoint. This diameter is going to be 10.4. Okay, then the distance from the top we're gonna do from the distance from the bottom, and this is going to be gear center, and then we just need to why can't I, bro? What the hell? What the hell, bro? Okay, so now we want to go remove through all direction. We want to go both ways though. Okay. Now I think we're ready to try to design the C-clip and the thing. The real question is whether or not this gear... Is this the center? I feel like there's no way that's the center. Let's try to add the let's try to add the worm wheel. Let's just get it out here. We're gonna mate this with that. Okay, but we need to offset by Z by, what is the distance? Stepper width over 2, probably. Okay, and then I want a section view because there is no way that's right. That is so wrong, it's crazy. Why is it so wrong though? Oh, damn. That's so annoying, bro. That's so lame. Okay, let's do a section view and we can see how bad it really is. We want to look at this. Then we want to go, that's good enough. So first off, you can see it's digging into the thing. So there's some calculation that's like totally wrong. I don't know why, because the module is 2 here, which means that... What is the module? The module is the... Oh, sick picture. Okay, so the module is the pitch over pi. pitch times Z over pi. Yeah, right. Module, yeah, that's what, okay. The module times the number of gear teeth equals the pitch diameter. The pitch diameter, okay. I'm hungry. I need to make some food. Okay, so what is it that we have wrong here? We need to make sure these things mesh, otherwise it's just not going to work. Oh wait, what is that? Is that interference? Is red has got to be interference. It's because we pulled it back. Oh, well, I'm glad that I looked at this. So we could either increase the hub depth, which I'd rather not do, or we just go to the worm drive and we take this face and we just extrude it, remove by 5, by wall. Oh, no, is it wall? We want it to be 3, actually. If we do it by 3, and then we go back to worm ass, I guess, I don't know why, though. That should be good. Oh, and actually you can see here, wait, can we take the, dude, I wish there was a better way to, like, go to edit the section view. Ugh, it's just, like, lame. Okay, where can we see it? Oh, it's because of the rotation, actually. That's why it is. But, all right, so if we do this, and then we rotate, can we rotate it while it's... Okay, that's pretty good. Okay, so if you see this, see that? That's no good. So we need to actually increase the depth of that. So is that this? Minus wall. If we just add 2 to it, is it gonna work out, or are we screwing ourselves? Just add 3 millimeters. Dude, that thread creator is so slow. Especially with the move face. Okay, so let's look at worm ass again. All right, so now we have a little bit of room there. I actually don't want any room, but it doesn't, I don't really care enough. Yeah, so look at that. The red is definitely interference. So what we need to do is go to the worm drive and look at this. The pitch is 2, though. What does that mean? Oh. I wonder if there's a feature. I mean, they're all helical, so I won't be able to really tell. Um,
basically split this in half so that we can get the teeth, so that we can then make the worm gear. Okay. So to do that, we're going to use our split tool, okay, which is right here called split. We're gonna click that. Parts or surfaces to split. Well, we're just gonna choose this dude right here. Entity to split with. I'm gonna choose the right plane, and then I'm gonna green check mark it, and I have 2. Okay. So I'm gonna go over here left hand side. I'm gonna go down here to the bottom, and I'm gonna hide part 1. I'm just gonna click on the eye so it goes away. I'm then gonna put a sketch on that. Okay. And all we need to do here is we basically just need 1 tooth. Okay. And maybe a valley. But so what I'm gonna do is I'm gonna project, use or project, and I'm gonna come in here and I'm gonna choose the lines that make up the valley, and then 1 full tooth. Okay. And green check mark that. And then I'm gonna come over here and I'm gonna right click, copy sketch. All right. I'm then going to add a new part studio. Put a sketch on here on the right plane. I'm gonna draw a 1-inch circle. It doesn't have to be 1 inch, or you can make it bigger if you want. Just the bigger you make it.
I gotta make some breakfast. I'm freaking starving. Okay, I feel like we're getting close. I just hit a wall. That's it. But I feel like we're actually kind of close. I mean, if you look at this, it's sort of there, generally, position-wise. It is a little frustrating, though, that in general, that it's just not easier to make, like, these kind of mechanisms. Like, again, it's one of those things. It's easy to specify and then super hard to, like, implement. But it's like, why is it hard to implement? I don't understand. Like, because if you look at this, let's see. It's like 1, 2, 3, like 3 and some change of peaks for one of these teeth. Oh, is it just by pi? The pitch just needs to be multiplied by pi, I think. Can I do that? Is that, am I crazy? Is that just like a random guess, or is that for real? First off, I wanna just move this out and move this back because I don't really want to deal with that at the moment. I want the nice faces. And then here, this pitch is gonna be 2, and then I think I should be able to just do pi times 2. See that? Oh, that looks pretty good. So wait, can we take this fasten and actually say that it's not fasten, but it's a revolute? Okay. It's a little low, right? Let's see what happens if we take. I believe what you have to do is you have to go here and then you have to do this and animate. Oh, that's so great. Yeah, that's exactly what we want. We just want to flip the direction. Okay, cool. Yeah, but it's not meshing well enough. I wonder why the math is wrong. The height of this thing from the very bottom is going to be wall plus stepper width over 2 plus the worm gear diameter or radius. So this is the top. So that should be that. So if we were to end this, we're going to just take... it's going to be hard to measure that. I don't really know how you measure that. I'm also curious to see how we're going to print this. We could try to print it from this face, maybe. Kind of looks like that has a taper, but I don't really care about the taper. Is that? No. Okay. Okay. Maybe we should just print this. All right, so we're going to do a new thing, and this is going to be called the worm spur cross beam or whatever. So this is going to be pretty easy, I think. So let's just how do we want to do this? Do we want to just start with a cylinder, or do we... No, let's do the hard part first. So we're going to do this. We're going to make... Okay, so we're going to make this 10. We're going to extrude this by like 3. Then we're going to sketch on here, and we're going to make this like 8. And we're going to extrude this by like 3. Then we're going to sketch on here. And we're going to extrude. We have it all? No. Extrude this. And yeah, this is going to be like... So what is the distance? It's going to be... So we probably want like 3 there. So it's going to be like 3 plus wall plus stepper width plus wall plus 3. So 6 plus 10 plus stepper width. Okay, so this is going to be 2 times wall plus 6, 2 times 3, we'll say that, plus... Wait, do we actually want that? Wait, I'm trying to figure out... How do we want this? Maybe we want the... If we do it right, we could probably actually do... You make this 12, you make that 10. Okay, how about that? So we go to this first sketch. We make this 12. We make this 10. And then we can just keep this going all the way to... So this is going to be... and it's going to be 0, but we're going to give it 0.4. So let's do 0.4 times 2 plus 2 times wall plus stepper width. Wait, but actually we don't even want to do this because we kind of want this whole thing over 2. And then we're just going to mirror it on the top. Bro, what? Oh, there we go. So we want this over 2. Okay, then we're going to make a plane. This whole, yeah, that's fine. Add mirror plane. This, oops, not that plane. We can just do this. Merge scope part 1, like that. No, wait, but you can't do that. Yeah, that's not going to work. I don't know what the hell I'm talking about. You can maybe do it one-sided, but that's kind of dumb. So instead, what we're going to do is it's going to be 10, and then go to 8, and then the width of the C, the outer diameter of the C is going to be 12, and then it's going to go back to 10. And then here's the wall. So you have the wall. Okay, so let's do that. So we're going to switch it back up. So this is 10. This is 8. Okay, and then how high did we extrude this by? 3. That's fine. And then this extrude. Wait, what? I'm not sure what happened there. Wait, let's look at this sketch. Oh, wait, maybe we just have to select the faces properly. Oh, yeah, because it was, okay. And this has that formula still. Okay, that seems right. So now what we need to do is add that. So we're going to delete. So let's turn off section view. We're going to delete. Well, we don't have to delete it. So this is going to be the cross beam. Okay, we want to mate. Yeah, this center to here, right? Oh, that's the 0.8. If we do, let's test if that's 0.8. Wait, what the hell is going on here? This face and this face, 0.8. Okay, so we just need to change this fastener to have an offset of Z of what, 0.4? I don't really care about the mate. So, oh wait, but actually, this doesn't work because nothing is preventing this from slipping. Oh, I forgot to show you guys this. So I'm trying to. So we have the hopper. So here's the hopper. We printed this yesterday. I haven't actually assembled it. I was hoping to do it today, but I'm not going to be able to do it today. But then we need something for this outlet. There's a hole at the bottom here. And I bought this big ass tube at Home Depot. And it's the only thing I could find with like a 1-inch inner diameter. So everything else that I got was bigger and like way too thick to flex. Like we're gonna need it to flex as the thing moves up and down. What's up?